So today we are simplifying radicals. In a previous video, I showed you how to simplify square roots. But what if the radical isn't a square root? What if it's a cube root? Or a fourth root? Or a fifth, or a sixth, or a seventh root? It turns out you can simplify any kind of radical using pretty much the same process. And I'm going to show you how to do it here. Okay? So for cube roots in particular, what you want to do is find the biggest perfect cube that divides into the number under the radical. In this case, 250. Now, sometimes you get lucky and you have a number that you just know the perfect cube that divides into it. So here's a list of my perfect cubes over here. Here's my perfect squares, here's my perfect cubes. I happen to know the cube root of 125 is a perfect cube, and 125 goes into 250. 125 times 2 gets me 250. So what I can do is I can break down this cube root as the cube root of 125 times 2. Because 125 times 2 is 250, and 125 is a perfect cube. Now, why is that helpful? Because when I break this cube root apart, the cube root of 125 times the cube root of 2, when I break that apart, I know this is going to be a whole number. The cube root of 125, we just said, is 5. The cube root of 2, still irrational, so I'll leave it as a cube root of 2. Or, when we multiply a whole number times a radical, we don't need the times symbol, we just put them next to each other. 5 cube root of 2. That is our simplified cube root for the cube root of 250. We just simplified this radical. What we did was found the biggest perfect cube that goes into 250 and took the cube root of it so we could take that number out from underneath the radical. And we made the number under the radical as small as possible. And that's how we simplify it. Okay? So it's really useful when you know the perfect cube that goes in it. But what if you don't? All right, what if you have a number where we didn't know the biggest perfect cube that went into it? Like the cube root of 324. Now I happen to know 324 is a perfect square, but unfortunately this is a cube root, not a square root. And I don't know. I could guess and check and figure it out, but let's say I just don't know what the biggest perfect cube that goes into it. We can figure out what that biggest perfect cube is by breaking this down into prime numbers, okay? And for that, we need a factor tree. All right, so 324, I know 6 goes in there. All right, 6 times 5 is 30, remainder 2, 6 times 4 is 24, so 6 times 54 is 324. And if you didn't know that, you could have done 2, you could break it down by 4. I just happen to know 6 goes in there, okay? And 6 is not a prime number, so we can continue to break this down. And 54 is definitely not a prime number, so I can break that down, 9 times 6. All right, we're almost there, though, because 3 is prime, 2 is prime, 9 is not prime. I could break that down into 3 times 3, and I could break down 6 as 3 times 2. All right, and then I'm going to drop these other guys down so everything lines up. All right, so notice, I've got all prime numbers now. Okay, so I've broken down 324 into all primes. Now, how is this helpful? Because in order to find the biggest perfect cube that goes into 324, what I do is I look for trios, groups of 3 of a kind, okay? And if you notice, I've got 3 3s right here. I actually have 4 3s, but remember, I'm looking for trios, because for a cube root, I'm looking for trios. If it was square roots, I'd look for pairs. If it's fourth roots, which we'll do in a little bit, we'll look for groups of 4. But for cube roots, I'm looking for trios. And there's only one group of 3, one trio. Like there's a pair of 2s, and then there's an extra 3, but we don't need that extra 3. So what we're going to do is just take the trio, and we're going to multiply it together. 3 times 3 times 3 is 27. Turns out that is the biggest perfect cube that goes into 324. Okay? But we're not done. Multiply the extras together. 3 times 2 times 2, that's 12. And that's the other number. All right. So in other words, 27 times 12 gets me 324. And if you're not sure about that, you can always double check it. 27 times 12, 324. All right. And 27 is the biggest perfect cube that goes into 324. All right. Now, why is that helpful? Because, again, we can break this apart. We can break this down into the cube root of 27 times the cube root of 12. And we know the cube root of 27 is 3. And the cube root of 12, we're just going to tack it on afterwards because that's irrational. And guess what? We've just simplified the cube root of 324. The cube root of 324 is 3 cube root of 12. All right? So by making a factor tree and looking for trios, I was able to find the biggest perfect cube that goes into 324. Okay? So for square roots, we would find pairs. For cube roots, we find trios. And guess what? For fourth roots, we're going to have to find groups of 4. And again, we would need the biggest, I don't know, number that's fourth rootable that divides in 352. All right, so what we're going to do is, and I definitely don't know that off the top of my head, I am going to break this down so we can simplify the fourth root of 352. All right, 352 is kind of a weird number. Let's try 2 times 176. And 176 is even, so that's 2 times 88. I'll drop down my 2 to keep everything lined up. Here we go. 88 is 11 times 8. So we've almost got this. And 8 is 2 times 4. Drop down everything else. And it really does pay to drop down everything else so everything stays in line. We've almost got it, but I've got to break down that 4 as 2 times 2. And I think now we have all primes, don't we? It looks like it. All right, there it is, all lined up. All right, so if I want the biggest number that divides into 352 that I can also take the fourth root of, what I'm going to do is look for groups of 4s. All right, and if you notice, pretty obvious here. 1, 2, 3. There's 4 2s right there. So there's my group of 4. And I've got some leftovers. So I'm going to rewrite the fourth root of 352 as the fourth root of 2 times 2 times 2 times 2, 16, times all the leftovers, 11 and 2, 22. And again, if you're not sure if that's correct, you can always pull up in your calculator and go, is 16 times 22 equal to 352? Yeah, it is. All right, so we're in good shape. All right, so why is that helpful? Because we can rewrite this as the fourth root of 16 times the fourth root of 22. And the fourth root of 16 is 2, which we kind of already knew because 2 times 2 times 2 times 2 got me 16. And the fourth root of 22 is irrational, so I leave it like this. And guess what? We just simplified the fourth root of 352. And I don't even know my perfect, what is it, fourth power numbers, all right? But because I was able to follow this method and look for groups of 4, I could figure out how to simplify the fourth root of 352. All right, so the key to this is the same even with square roots. If you don't know the biggest number that goes into it, break it down to prime factors, find the group of, in this case, 3 because of cube root. Down here, it was groups of 4 because of fourth root. If it was square roots, find pairs and multiply them together, and that's your biggest number that's going to go in there. Okay, so hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.